Hey everyone, let's try to do some 2.4. It's on measures of variation. This is the section that the highlight of it will be standard deviation. So our goal here is to calculate a standard deviation based on a data set. So let's try it. Here we have a data set, a list of receipts from one night at a restaurant. We're gonna assume that this is the population, meaning that this is all of the receipts from the night. Okay, because that will matter when we get to the formulas. But the first thing we'd like to do is a little bit of review here, find the mean, median, mode, and the range. So if you want to just hit pause and try that on your own, and then when you're ready, hit play, and then I'll just have them all appear. Okay. Okay, so we have these values. So again, the mean is just found by adding up all of the values and then dividing by 10 because there's 10 of them. The median, you have to put them in order first and then just find the middle one, which because there's an even number of them, there is not a middle one, there's a middle two. And so you'd average those two together. The mode is just what is occurring most frequently, where in this case, we have two of those because there's a tie, both 42 and 50 repeat. And then the range is just the maximum minus the minimum. So the 56 minus the 38. Hopefully that's 18. Okay, let's get into this calculation of the standard deviation. What we're first going to find are the deviations of each data value from the mean. Okay, so in other words, when we have this table here, the first number is 44. The question is, how far away from the mean is that value? So what I'm going to do is just a little subtraction, 44 minus that calculated mean. So on these problems, it's really important to get the mean right because you use it a lot. Okay, so if the mean's wrong, the whole thing just kind of falls apart. And this is negative 1.4. Yeah, okay. If I did 50, I'm doing 50 minus 45.4, right? So all of them are just subtracting that 45.4 all the way down. That's 4.6. Okay, so I'm going to pause again. Go ahead and try those if you want to fill them out, or just wait and they'll appear. So not to waste too much time going through these calculations. So pause. Okay, so here are my values. Again, I just subtracted 45.4 from each of the data values and I got those. Okay. What we're after here is the spread of the data set. Right? Kind of on average, how far are these values differing from the mean? So why not just stop here, right? Because we have a nice list of deviations. But if we took the average of just those, because of the negatives, it would turn out to be equal to 0, right? So we don't really want to add those up and divide by 10. You'll get 0 every time. It doesn't give you any information. So what statisticians have done to get around that is now we're going to take each one and square the number, right? Multiply by itself. Because if you square a number, it's always positive, right? Even if the number is negative, negative times negative, positive. So we'll get a bunch of positive numbers. Okay, so on my next column, I'm squaring the number. So I can just, in my calculator, type 1.4 and hit the squared button, or just multiply by itself, 1.4 times 1.4. I get a 1.96. 4.6 squared, 21.16. Right. When I'm doing this, if I see a negative, I don't even put it in the calculator. I'm just doing 7.4 squared. I just know it's going to be positive, right? So that's 54.76. So again, if you want to practice this, try it on your own and then check your answer. I'm going to pause it again and then do them. Okay, so pause. Okay, so there are my squared values. I hope those are correct, and that's what you got if you were doing it. So there we go. Okay, so far we subtract the mean from each value, square each number. Okay, now if you notice what we want to do here, this symbol means add things up. So add up all of those deviations squared. So now I'm taking that column and just adding them all up. 1.96 plus 21.16 plus, etc., all the way down. And if you do that, you should come up with 278.4. You could take my word for it, or you can double check me right now, okay? Okay, so that's what the table is for, is to get that sum of the deviations squared, all right? And then now we get into the notations, the formulas, and the conclusion of this. So there's two things here. There's variance and standard deviation. So the population variance, this is the symbol for it. Anytime you see that, that's called sigma, it's lowercase sigma. Sigma squared is the symbol for population variance. And what it says to do is on the top, notice the top is what we just did, right? So that's the 278.4. That whole table was to figure out the top of that fraction. Okay, and then the bottom is a capital N. That's the total number of entries in a population. So in this case, we had 10 entries. So if I take that and divide it, I gotta do that in my head. Just move the decimal over one place. That's 27.84. This is called the population variance. All right. Next, how do we turn that into a standard deviation? There's one adjustment. You notice here in this formula, it's basically the same thing. You just have that square root over the whole thing, right? And there's no square on that symbol. So when you just see sigma by itself, that's standard deviation for the population. So for this one, I'm going to take what I found for the variance and just square root it. So find the square root button on your calculator and take the square root of 27.84. And let's just round this to 2 decimal places, or how about 3? Let's go 3. That looks nice. 5.276 is what I'm seeing. Okay, that is the standard deviation of this data set. Meaning, what that means is, on average, data values are going to be about $5 away from the mean. Okay, so it's a one number that gives you a clue about how this data set is spread out. Right? The higher that number, the more spread out the data set will be. A lower standard deviation, the values are really close to the mean, close together. Okay. Okay. Those are population variance and standard deviation. There's a slightly different formula for the sample standard deviation, right? And I guess also you could do sample variance. Notice the difference. Well, symbols are different. When you see S, that's standard deviation for the sample. And then you have an X bar in there, sample mean. And then down here is N minus 1. That's the sample size subtracting 1. Okay, so let's assume that this data set was a sample, right? So it wasn't all of the receipts for the night, just a sample of 10. What would that standard deviation be? It's going to be a little bit of a different number. The top value is exactly the same. That 278.4. Nothing would change. That table would be the same no matter if it's a population or a sample. The big difference is what you divide by, because now it's n minus 1. So it's 10 minus 1. Okay. So in my calculator, I'm going to figure out 278.4 divided by 9 and take the square root of that. You can probably do that all at once into your calculator. If you just put square root first, depends on your calculator, but you have to play around with it a little bit. Or you could take it step by step. But this, if I round to 3 decimal places, is 5.562. That would be the sample standard deviation. Now, how do you know which one to use? Population standard deviation or sample? Look at the wording of the problem. Is this data set you're using a population or is it a sample? Because if it's a population, you got to do the population way, right? Capital N. If it's a sample, you got to remember to subtract 1 from the sample size, okay? And that's pretty much it. All right, so a little bit of work involved, kind of tedious, right? Because a lot of calculations, but once you get the system down, it's not too bad. Last thing we'll do with this video, is just outlining some symbols here, right? So population variance, the symbol for it is sigma squared, right? Whereas sample variance would be S squared, okay? Standard deviation is just without the squares. So for population, it's sigma. Standard deviation sample is S, like we saw right there, S, right? Now, we never found a sample variance, but we could. They're closely related, right? If you know S and you want to find S squared, you can just square that number, multiply by itself. That's how they're related, okay? Mean. So our symbol for population mean is always going to be mu, and our sample mean will be X bar. Number of entries or population size is capital N, and sample size is lowercase n. Okay, and then a deviation is a subtraction problem. So for a deviation, you're going to take X minus mu for a population, X minus X bar for a deviation. You probably want to get used to all these symbols because we're going to use a lot of letters and maybe the whole alphabet and the Greek alphabet too. There's a lot of symbols and stats. So if you start making a little glossary of the symbols, that helps. Okay. We're going to do this later. It says use technology to do the calculations. We'll do that when we get to StatCrunch. But for now, we just have already calculated those by hand. So we're good there. Okay, so I'm going to stop this video here and I'll continue in the next one. Hope all's well. Talk to you later.